Goodness, all the things that could go wrong. Let's just remember what we were doing last time while it's thinking about all those things. So here, we were talking about functions. We learned how to make functions. They're very important. It's a way to give a name to not just a value, but to a computation, right? We say double, and you can give it something. That's like where the argument's going. You can get it into a variable that's just part of the function and use that to compute something and give some answer back, usually with the return, all right? So this part where you do your computation is indented. It's called the body of the function, and it's very, very useful. Right? So we saw some functions have a bunch of lines, right? We learned about all that. It's wonderful. And then once we have functions, we can combine them with tables. We can say, hey, I got a table. I'd like to apply that function, please, to however many columns that I need, however many things that that function takes. Like apply it to the x column and the y column and stuff like that. So where are some examples of that? Oh, it finally turned into a 1. Great. Yay. So let me just quickly try to run all these. Run selected cells so that it has everything from last time again. But while it's thinking about all that, oh, and it has that error, sorry. Gotta do that. Gotta do... Can I not select anymore? Shift. All right, I'm just gonna click the plus, the sign a bunch of times until it works. Whee! One way or another. And if I scroll now, finally, you saw us applying functions to tables here. So like if I have this elevation column, we applied this cutoff at 0 function that messed with that column. It took that, it applied the function to every row, every piece of data in that particular column because we passed it like that. If you had a function that needed multiple things, did I show that to us? Not quite yet, and I'll show that to us later then. But that's a thing that you can do. You can have a function that takes multiple things and you can apply it to more than just one column. So yeah, we learned how to group. We learned very fun things with functions in mind. So I think what I want to do next is show you kind of how you could do grouping a little bit fancier. So there's something called pivot that's a little bit different. So grouping, it's going to like separate based on a categorical variable. So like we can group our, where was that? It was the first grouping that we did. So like if we have our cones table, right, of all of our ice cream cones, we can group by flavor, and that's a categorical variable. And what it will do is it will find all of the different things that we have for flavor. It'll separate them and find only the unique things like bubblegum and chocolate. It'll only write it once, and then it will aggregate based on all the things. It computes like, okay, find me all the bubblegums, let me do something with all the bubblegums. Find me all the chocolates, let me do something with all the chocolates. By default, it's just going to count them. All right, that's what grouping does. It brings them all together under the flavor category, and you can tell it to do something other than add them up. You can tell it to like take an average, and it will take averages of numbers and forget about other things. You can tell it to just list them all out. You can tell them to sum up all the things that you could possibly sum up. Can't sum up colors. You cannot sum up strings, but it can, again, sum up things like that. So it's grouping based on all the different categories of the flavor column. All right, is that making more sense? Is that all coming back to our brains? So remember that. If you want to group on 2 axes at once, it's called pivot. So let me show that to you. So instead of group, there's one called pivot, and that's going to cross-classify. So here, I'm glad I don't have to use that. Instead of group, it's called pivot, and it's right next to it on this documentation page. So you give it 2 things. You give it 2 things at least, and it's going to make what's called a pivot table. So like if you have this, like here's your cones table kind of. If you pivot based on flavor and color, it's going to, these are 2 different categorical variables. It's going to put the first one as the columns, and then the second one as the rows. And again, by default, it's going to count. So how many dark brown chocolates are there? There's 2. How many dark brown strawberries are there? There's 0. Is that kind of, you see what it's doing there? It's like it's cross-classifying. That's kind of grouping twice at once. So cross-classifying, it's always going to be categorical variables, because usually when you have numbers, you don't have things like that can line up multiple times. You don't have like the same thing a bunch of times, but it's going to make you a grid, and you need to give it two things, always, at least. The first thing is the one that's going to be the column labels, like it's going to be the variable that forms the columns. And then the second thing is going to be the variable that forms the rows. It's going to find them all the unique values, and aggregate based on those. So by default, again, like group, it counts. All right, but you could tell it to do something else with all the things that it's putting together. You could say, no, you have to give it two extra things. It's called values and collect. Values equals something and collect equals something. But you can say, you know what, I'd like you to, this is kind of a perfect example because it's got cones still in our minds. But you can say, do that based on flavor and color again. I want you to pick out for each of those ones that are like dark brown chocolate, all the things that they have in common. Don't just count them up. I would like you to produce, like, get all the prices for all these categories, and then I'd like you to apply this function to all those prices. Does that kind of make sense? So it's going to find the prices for dark brown chocolates. It's going to bring them all together, and it's going to sum them up. Does that make a little bit of sense? That's kind of how it's working. It's kind of like the group aggregation functions, but it's going to do it like in 2 dimensions. Okay, that's what's going on, and that's why that looks like that. So it's values equals some column label, and then you say collect equals the function you want to apply to all the values of that particular column once it's been cross-classified. All right. So the examples are worth a million words here. So let's do all that together. So pivot. Very similar to group, just like 2 dimensions at once. So pivot, in theory, I have my cones table imported. Perfect. So I'm just going to do most of those examples again. So you can say cones.pivot. I would like you to cross-classify based on the flavor. So the flavor values are going to be on the columns. That's the one you get first. And then color. All right. You could have done it in the other order. It does not matter. But what it will do is it will cross-classify. We'll find all, like, okay, all the different colors are dark brown, light brown, pink, and white. All the different flavors are bubblegum, chocolate, strawberry, and vanilla. And so, like, how many of which combinations are there? There's 0 white bubblegums, but there's 1 white vanilla. Stuff like that, okay? There's 2 pink strawberries. So by default, it's going to count after it does this cross-classification, but you could have done something different. You could have been like, you know what? I'd like you to pivot on flavor and color, and take, kind of like grouping takes a bunch of things all at once. It produces, where did I say that? Kind of like this. It's going to bring them all together, like give me the list of all the things, and it's going to apply your function to it, whatever function you provide. So you got to give the value, the column label, as well as the thing you want to do. So like values, the values I want you to use after you're cross-classifying. Once you got these all together, like you have your 2 pink strawberries right there, you got your 2 dark brown chocolates, your 1 light brown chocolate right there. The values I want you to deal with right now are in the price column. Use the prices, please bring them all together. So like, look at the 2 prices for the dark brown chocolates, it'll go there. Look at the prices for the 2 pink strawberries, it'll go there. And apply the following function to all of those things that they have in common on those levels. So you say collect. How do I want you to collect the data for those things that they have in common? You provide the name of a function. So you could say, I guess the example here was the sum function. You could have been like, what's the average price? np.average. Apply the np.average function to the sequence of things that's all together there. So apparently the average price of a light brown chocolate cone is $4.75. For pink strawberry, it's $4.40. But you could have done some, you could have done other things. So that's how it's like, it's bringing because there's 2 of them, 2 pink strawberry cones. What do you want to do with their values? What do you want to do with their price values? I want you to average them together. Does that make sense? It's a little silly, a little weird, but that's, I think, most of the idea. Do you see it? See the vision? So let's see. Do I want to show you? Well, I want you to try it eventually, but I want to show you something with a cool example, with a cool data set that kind of makes pivoting make sense. So we have from the lovely textbook, we have this weird CSV file. It stands for education and income, educ inc. And what it has is a bunch of people. All right, so let me read in this table. If you want it, it's educ_inc.csv. And it has education, and income data. So it's like for people who like went to college, people who went to high school, like how much did they end up making in their life? So they did like a survey. So that's the one we want. And here's what it looks like. And they got a bunch of different years. They followed some people from like 2008 all the way to like 2014, I think. And so we'll pick out those in a second. But here's kind of what the table looks like. You got some of them are children. Some of them don't have, and of course the children don't make a lot of money. But some of them, even the children, have gone to college a little bit, which is kind of cool. Like, all right, at the start of the year, we got male children between 0 and 17 in 2008. The ones who went to college and had this kind of income, there were 1,304 of them. That's kind of how you're reading this file. All right, so let's take the year where the most recent data is probably the best example, and that is 1/1/14 at midnight. Apparently, that's how they do it. So give me all of those. So only where it's that, and then we'll also do where the age is where they're not children, because I don't think we want to deal like with the income of children, because usually they don't make a lot of money, right? Hopefully they don't have to. So where the age values are not equal to, and this is a categorical variable, it's a string 0 to 17, like that. So let me take those. It's like that's the table I want to look at right now, and I'll call that Education 2014. So I've just filtered it, and now I'd like to pivot in a cool way. So let's not really care too much about, because like some of these are the same, right? Like the males and the females, but we've got no high school diploma, 75,000 and over. Like we have counts for all of them. We'd like to combine those in a way. So like, look, let's forget about the year, the age, the gender, stuff like that. So let me only take, because I want to aggregate, let me select only column 0, 1, 2, so 3, 4, and 5, because I don't want to type all those out. So give me columns 3, 4, and 5, please. That's just those: educational attainment, personal income, and population count. And let's call that one Educ 2014. Like that's the one I want to use from now on. So I'm just getting the table ready. And now let's pivot, because we have a lot of things. We have male and female. Like some of these are the same, right? And so we can aggregate them together and do things, which is nice. Let us pivot this table now. Because one thing that you probably want to know is like, all right, if you have a certain amount of education, how does that correlate with the amount of money that these people have made? That's probably the question we can ask with this data. So let's pivot based on those ideas. So pivot with the columns being educational attainment and the rows being personal income. And it doesn't really make any sense to say Shift Enter right now, because it's like, yes, there's 4 of each. Like that's what they took, right? Like male and female of certain age categories. So like there's 4 other age categories. This is very useful data right now, isn't it? So it's kind of silly. And instead, we have this numerical variable right here, population count. That's probably what we care about. Let's aggregate over those values. So the values I want to use as we're pivoting are the values in the population count column. And how do I want to collect them? How do I want to bring them together once we've brought in the personal income for the bachelor's the bachelor's degree or hire people with very low personal income? Like, what do I want to do with their population count? I probably want to add them up. Like, how many people were in those categories, right? That's what we want. And so it's collect equals, call the sum function on all those values. Does that make sense what I'm asking here? I'm like, all right, pivot based on educational attainment. So here's educational attainment on this axis. Here's personal income on this axis. And then it's cross-classified. And I'm taking, for each of the ones that share college less than 4-year degree and they made this amount of money, I'd like to see how many people there were. So there were a bunch of different rows with different population counts. I want to bring them all together, the ones that have all these in common, and add them up. Does that make sense? What's going on there? So it's a little complicated to get there, but the idea hopefully makes a decent amount of sense. So Yeah, I think it kind of makes sense that no high school diploma and a lot of money usually doesn't happen very often, but we can graph that. We can see cool things. So let's see that. Let's do, I don't know, which ones do we want here? What's the best thing to say? So let's do, we got our total. Let's call this something. It's a, oops. This is a table. Let's call it something. Let's call it totals. And, well, we can see, you know what we have actually? We made a function a long time ago. This was part of our written nice question. We have this percents function. Remember how we used that? As like, we gave it takes an array of things, and by default it gives 2 decimal places, but it takes like a bunch of counts, and it figures out what were the percentages instead of just the raw counts. I think that would be a good function to apply to this data. Like what's the percentage of people who like had no high school diploma and made this much money or this much money or this much money? It kind of makes sense to not deal with the counts, but with the percentage of the people who had no high school diploma, but the percentage of people who had a bachelor's degree or higher. So I can take that function that we made. So remember how we used it. It's just like you give it an array of things, a sequence. Where is it there? Just like this. And that's kind of what it's getting when we use pivot or when we use group. So we can apply percents. We could collect based on percents. That's kind of cool. So let's try that. So here's what we could do there. We could say, take my totals. Let's do, I don't know. Let's take for sure the first column. So select 0, like that one, personal income. And then I like to attach to it not this exact same column with bachelor's degree or higher, like with columns, like I want to attach it in a different way. So like make a new column also called bachelor's degree or higher. But what I want you to do with it is take the original one. This is what is it? Totals dot column. It's column number 1, right? That's the one. I cannot use an apostrophe because it thinks that the string is over, so I have to use double quotes for this one. That's why it was unhappy. There it goes. So, okay, bachelor's degree or higher, and totals column 1, that's this again. So it's like, I would just be reattaching it if I said it like this, but I can say percents. Percents on that. That's one thing we can do. You could also give that to pivot in a different way if you wanted to like give me the percents of the people with that in mind. What else? And let's do the same for no high school diploma. So the next column I want in there is, let's do no high school diploma. We can apply our percents function to that, just to the column. I think that would be the easiest. But you could also aggregate based on that if you had something. Which number is that? 0, 1, 2, 3, 4. So does it make sense what I just did there? I took, just like, give me that column again. And then I took this one and this one, but not the raw numbers. I gave them to our percents function. So it's like, instead of 575,491 people there, it's like, of the people with bachelor's degrees or higher, it was 6.75% of them. Does that make sense? So that's kind of more interesting information, I would say. It's easier to read. And so now we can do, like, we have this table, we can call it something. That's a distribution of values. And these are categorical variables for personal income. And these are numbers. So that kind of screams we can make a bar chart. So it can be like dist.bar h on just like personal income or index 0 of the columns. So that is probably a graph that we want to make. So it took us a pivot, a couple function calls. That's kind of nice that we can make that. Now, does the process make sense of how we got here, though? Like, it was a little weird, but that's kind of cool. You can see that, okay, it usually is the case that people make a lot more money when they have a bachelor's degree. It's more uncommon to see low income for bachelor's degree holders, and the flip is true for no high school diploma. It makes more, usually when you don't have a high school diploma, it's more likely that you make less money, at least for the people that were surveyed here. So that's kind of cool to think about. And that's fun. So how do we get here? We said, Well, we got our table, our original table, and then we pivoted because we had a bunch of like male, female things for different age groups, and we don't care about that anymore. We want to aggregate over all of that, so bring them all together. Like all the bachelor's degree or higher, where the income was this. Some of them were like 20-year-olds, 30-year-olds, 40-year-olds. Like bring it all together and use the population count as the thing I care about, and use the sum function to add up all those different population counts where they all shared this educational attainment and this income. So that's how we got there. That was a pivot. And then we took the ones we cared about and made them into percents because it's easier for us to like relatively compare things now because there's maybe different numbers of people in those categories. And then we can make a cool little bar chart based on that and get some information that kind of makes sense. Does that process make sense to us? Any questions about how we got there? Because it is kind of cool. So that's pivoting and like why you might want to use it. I guess you could have, I should show you like the equivalent, like go back to what we did here for like the cones and the flavors and stuff. You could have done something similar with grouping, but it'll show you in a different way. So like grouping, there's a way to do it based on flavor and color because I showed you that you could group based on two things at once. Like give me all the flavors, you put it in this little list-like thing, flavor, color, with these square brackets. So like group based on every different combination of flavor and color, every unique combination of those. And I'd like you to call the np.average function on all the things that are in those categories. Whee, there it is. And so again, it kind of does the same thing, but it shows it to you in like one dimension rather than two dimensions. It's like there's still bubblegum and pink, and they average all the ones that were together averaged together to 475. You still see it, but kind of sometimes it's easier to read it off like that. Like you have options now, all right? So I think that's all that I wanted to say about pivoting. Are there any questions about like the difference between pivoting and grouping, anything like that? All right, I want you to try it now. So I'll give you like this example. I think is probably a decent one. That is a useful one. That's how we use it usually. I'd like you to try. So please, here's my example code as a guy. That's kind of how you can call pivot. Look it up on the documentation page as well. But I'd like you to take the Titanic data set and try to find the total amount of money spent by the passengers on their tickets, but cross-classify by ticket class and survival. So let's look at that together real quick. So we've got, where's Titanic? Let me read it in for us real quick, and then I'll let you try it for a few minutes. So Titanic, do I have it already? I do not. Equals table dot read table data titanic.csv. Dun, dun, dun. So there it is. I'd like you to try, like we have survived 0 or 1, categorical variable technically, and then we also have their passenger class, like first class ticket, third class ticket. So I'd like you to cross-classify based on those two ideas. Like, what was their ticket class? Were they in first, second, or third class? And did they survive 0 or 1? And try to find the total amount of money spent by like the first class survivors, the first class non-survivors, the second class survivors, the second class non-survivors, but as a 2D table. Does that question make sense? So pivoting is the way to go here. You'll use a call that looks something like that, but I want you to care about their ticket class, whether they survived, and the computation you're going to deal with once you've got them in those categories is how much money did they spend on their ticket. So that's going to be this fare column. All right. Questions about the question before I let you try? See if you can do it and try to do the average, like if you get the sum very quickly and easily. We got plenty of time. I'll give you like a 4-minute head start. How about that? And then we'll do some cool things together after that. But just get an example of pivot in your brain. Go to the documentation if you need to. Read the table. And then you're going to align it. One of those, either depending on how you do it, the rows or the columns, it's only going to be 2, because like 1 for survive, 0 for not didn't survive. And then there's going to be 3 on the other axis, first class, second class, or third class. And what do you want to do once you've got them in those categories? You can probably make an interesting graph too, if we thought about this. I'll give you another minute to try it, and then I'll step in. We'll do it together. Yeah. That is always very loud. That's what wakes me up in the morning. Are there any questions about this question before I show you the answer? Or one way to think about it, at least. This is kind of a silly question to ask, maybe. Why would we make this table? Like, we want to see how much money was wasted by the non-survivors. Like, they could have stayed home and saved all this money. Something like that. Let's find out. So I want to say Titanic dot pivot. What I want to pivot based on their ticket class and whether they survived. And it honestly doesn't matter which one we give first, as long as we give them both. Let's say that on the columns, maybe we can do ticket class. So P class. P class. And then it was survived, capital survived on the other column. And so if we did it like that, we get the counts, which is kind of cool already. It's like P class survived. It looks like there were 80 first class passengers who didn't survive, 97 second class passengers who didn't survive. There were 119 third class passengers who did survive. Do you see how to read that? So that's kind of cool already. But what we wanted to do was not just count, we want to aggregate the amount of money they spent. So fare, the fare amount is what we're going to, those are the values we're going to use once we combine them into those categories. So use the values. So for all the people that have like didn't survive in second class in common, get them all together and pick out their fare values, capital F. And what I want to do with all those fare values that they have in common, I'd like you to sum them, please. Oops. What have I done wrong? Additional argument. Oh, sorry, it's collect equals sum. Excuse me, got to say its name. And it looks like there were, that's an interesting answer, kind of like, all right, the first class survivors did spend about, first class non-survivors spent a little over £5,000 in total on their tickets. The second class survivors spent almost 2,000 British pounds at the time on their tickets. So I don't know. That's one question you could ask. Does it make sense how I got there? Like that would be the answer. And you could also do like the average. What was their average fare? Like once you bring them together, do mp.average or mp.mean is the same. Like on average, the first class survivors spent more than the first class non-survivors. Interesting. Does that mean they preferred to save the rich people, the richest people? I don't know. Third class, it was kind of like, it was like a coin flip whether they survived or didn't survive. It didn't really depend on their fare, it seems like, which is kind of another cool, interesting thing that you get out of this when you try it. Are there any questions about like how to interpret this, how we got that? So I think it's a cool thing that we can do. I like it. What else? Okay, for fun, let's make a silly little function that's like, I would like to know at a glance what was like the min price that a survivor in first class paid and the max price that a survivor in first class paid. So like for each like column here, aggregate them, and like I'd like you to give me the max and the min all at once in each place. Like what was the max ticket price and what was the min ticket price? So that can be, I just give my own function to collect now. Here's what that looks like. So I'm going to make a function called give me the max and the min, and it's going to take a sequence of things. Max and min, we'll call it. And it's going to take some sequence of values, I'll call it S. And what do I do with those values? I want to give back at the same time the maximum and the min, because that's what it's getting each time. Like, give me the second, it's bringing together as a sequence all the second class non-survivors, all the second class survivors, and it's feeding it into whatever function you give there. So let's have it feed it into this. Give me back, return, an array, so I can have multiple things, right, of the max value in S, and then also min. Maybe min should come first. Does that idea make sense? It's like given some sequence, give it back an array of the minimum value as well as the maximum value. Does that idea make enough sense to us? Because you can call that now in here and be like pivot based on that, collect based on the max and min. Maybe I should have called it min and max. And now we see this. It looks like maybe they didn't have, maybe it was like a NaN and they didn't actually have, but maybe a first class passenger apparently paid nothing. All the way up to a first class non-survivor paid nothing to, like the maximum price they paid on their ticket was £263. It looks like the second class survivors, at a minimum they paid 10.50 up to £65. Like that was the min and the max, and you can see them all at once based on, because we gave all those values, we aggregated them, we collected them together and applied our function to the sequence of them. Like that's what we wanted to know. Any questions about that? That's kind of neat. I like that. All right. If we are good, there's one more like table-y thing that I want to do before we just practice. So joining two tables together, there's a dot join. And let me show that to you. So as this. You can say table, it's dot join. There it is. I don't know what the column it was, but you give two tables at once. You have the first table, and you say dot join with some other table based on a certain column label. All right, so this is not going to make enough sense. You think of it like it's surgically attaching things wherever they correspond, but honestly, it does not make sense until I show you an example. All right, so dot join is going to join two tables together. You give you say the first one's name, and you say dot join. You give the second one's name as one of the parameters. Well, let's do that. This is called join. So we've got our cones table. Let's go back to the easy cones table. Let's make another table. I'll call it like the ratings of all the different flavors. Ratings, and I'll call it, make a table, blank table with some columns. Let's call it kind, is an array of all the different kinds of, let's see, flavors that I have here. Let's say that I only have ratings for strawberry. chocolate, and vanilla. All right. That's my kinds. And then let's say that people have rated those kinds different stars. And like, I want to look at that. So make array, I don't know, strawberry was 2.5, chocolate was 3.5, vanilla was 4 or something. And so that's my ratings table. You will notice that there is a correspondence between the cones tables, most of the rows of the cones table, and the ratings table. They have flavor and kind, very similar things, yes? They have similar, almost the same stuff, right? There's just bubblegum missing from here. When you have that, when you have things in common, when you have a column of one table and a column of another table that have the same values, you can attach them together based on where they match. That's what join does for you. So you can say, hey, cones, join yourself with the ratings table, and I'd like you to use your flavor column. I'm gonna join your flavor column. That's the first thing you give. What column of you are you using to join? You're attaching that to the ratings table. You give the name of that table next. And I want you to attach to the ratings table where the flavor and the kind match. So it's join on the flavor and the kind columns. If it was also called flavor here, you did not have to say kind. So don't have to give the third argument if it was the same column name. So that will become apparent one day. But that's what you say. You say, cones, please join yourself. Join that table on your flavor column. Use the flavor column to match with the ratings table on its kind column. And it's going to attach. It's going to use as many rows. Oops. It's ratings. It's going to make as many rows as it can. It's going to pick out all the ones where there's a flavor and a kind, like they correspond. It's going to skip the bubblegum because of that. But like we had, it's also going to do it in that kind of order, which is interesting. But do you see what just happened? There was a chocolate light brown 475 up here. It kind of changed the order. But also there was a chocolate rating here that was 3.5. And it's going to attach the stars column based on that. So chocolate light brown, the rating for chocolate was always 3.5, so it's going to attach based on that and add in the stars column. The kind column goes away because it was the same as the flavor column, had the same values. Does that make sense what it's doing there? It's like it's attaching it based on, it's adding in the stars or whatever else was in this other table. The chocolate rating was 3.5, chocolate rating was 3.5. It's picking out of here and adding it in. The strawberry rating was 2.5. Apparently it's a bad strawberry batch. The vanilla rating was 4, and it's attaching that as a stars column. So that's what join does. You're joining yourself, your table, to another table based on where this column matches this column. All right? Is that any questions about that? It's a little technical, but I hope you can see like why it's useful. Like you have two things and they correspond. You want to attach them. Attach them together, please. Yeah, that's join in a nutshell. I think I have, if we're good, I have an example of just a bunch of things at once. Are we ready for that example? Just like to review everything that we're talking about in this chapter because it's a lot of stuff. All right, it's very cool. Your textbook has, I think, an older version of this or something, or at least the lectures from UC Berkeley, they used an older version of it. There is a ride share thing, and like not a ride share, but a bike share like service in San Francisco called Bay Wheels. Have we ever used that before? When we went to the city. Apparently that's a thing. There's an app, and like you can rent a bike for a while, and I think you can either have an e-bike or just a normal bike. Like that's a thing. But what these people have done, because it's San Francisco, of course, they have made all of their data public for all the people that have gone and like rented a bike for a certain amount of time. So we're going to analyze a lot of data right now. It's going to be great. So this is a very good example, I think, and it's called Bay Wheels. We're gonna look at all the people that took a trip in, I think, June, because that's when the latest data was available to me as I was like making this class. Extended example. Bay Wheels bike share data. So this is a fun one. There's so much data, by the way. Where did I put it? It's 25. It's this first thing. 2025-06 Bay Wheels trip data.csv. It's actually a zip file because it's so large otherwise. You can read in a table from a zip file. So right, even the zip file is 8.3 megabytes. This is the biggest data set that we're ever going to use in this class, I think. So this is fun to think of. There's hundreds of thousands of trips, I think. So it's like there's a row for every trip in the table. So trips equals, let's read the table. Read table. It's data / 202506 bay wheels trip data.csv. So it's a very large file if you want to get that and try it yourself. It's that. And so it's going to take a while to read it. It's going to go into memory. But there are a few 100,000 rows, one for each trip that was taken in June of this year. All right. And so here are all the different table columns. You got what kind of writable type. That was the type of bike that was rented by this person. Like there's a row per bike rental. So there's a class, either a normal bike or an electric bike that could have been rented. And we have the time duration, like the time period that they rented this bike. That this person, they rented it starting at 9:07 in the morning on the 30th of June, and then they dropped it off at 9:16 in the morning. So it was like a few minutes ride. It took this long. So duration is essentially end minus start in terms of seconds. It's 534 second ride to get to somewhere. And it looks like they went from this station to this station. And that's where like you can drop off the bikes and put them back. And that's how that works. And then member casual means like, was this person, when they download the app or use the QR code or whatever you use to get the bike, were they like, did they have a registered account? Or were they just a person like who was a traveler and they just wanted a bike, please, I don't want to make an account. Like that's what member versus casual means, I think. But those are the rows of the table. Does that make sense? So we can analyze this data in very cool different ways, and I think you can think of more than I can think of. But there are several 100,000 trips, one for every trip, I think, in June, like legitimately. So let's look at this. Let's keep track of short trips, because usually like it gets some of the people like they left their bike they forgot to return it or something. So let's whittle this data down a little bit to make it easier to think about. Let's get all of the trips that were less than 30 minutes long. All right, let's look at those, because that's like the commuter trips where the duration column, because duration is a number, where the duration column was the duration column values are below less than 30 minutes in terms of seconds, because duration is in terms of seconds, so it's going to be 60 seconds times 30 minutes, something like that. And so that will give me this table where the duration is smaller than whatever that number is. All right, so it's slightly smaller. It's still most of them. Well, there's only a few that were much bigger, so it's still most of the rows, and I'll call that below 30. Those are all the trips below 30 minutes. And what we can do to that table, with that table, is make a histogram and be like, all right, usually how long does it take these people who are riding for less than 30 minutes? Let's make a histogram based on the duration amount. Duration. So we can explore this data. And the units of duration are in seconds. And so if we want the table to be perfect, we say second as the unit. Cool. So it looks like most of, a decent amount of the rides, like not a lot of them are really short. I made these bins automatically, by the way. Made these 10 bins like almost up to 250 seconds. A lot of them were at least 6, 12, 18, 24, at least more than 4 minutes long. Like it's very uncommon for them to be less than 4 minutes long, because otherwise you'd walk, I guess. But then if it's more than 4 minutes, like as a bike ride, you're going to take the bike. And it's going to, you're not going to be riding for much longer than 1,000 seconds, however many minutes that is. Like almost, 10 minutes or something. So that's interesting in itself. Are there any questions about like what we could think about here? Like that's cool already. You can give to .histogram, you can make it more, you can make your own bins. You can tell it like, I don't want the default 10, but like make me a default number of bins, like give me 60 bins or something. Like you can look at it at a more fine-grained way, which is interesting, but it still kind of matches the picture that we see up there, just more fine-grained. We have a ton of data, and that lets us draw pretty pictures like this. All right. So that's the first thing we can do to explore the data. Still haven't really done anything from this chapter yet, but let's group things now. So let's we've got all these stations, like where these trips started, where they ended. Let's group by start station. Let's see where the most popular station was to like get on a bike. Maybe that's a station where there's not a lot of good other public transport. Maybe there wasn't a lot of bus lines coming out of there once you get off the BART or something. So below 30, let's group based on the start station name. Let's do it based on where these trips started. And well, by default, we get a bunch of counts, right? It takes a while to do all those counts. Let's sort by the count, because like by default, you get that new column called count. Let's sort by that, sort by count, and let's do descending. Let's find, because I want the amount, like how many, what was the station with the most trips starting from there? Because that's what this grouping and sorting will give to me, right? So it looks like a lot of people are coming into the Caltrain station, and they're getting off the Caltrain and taking a bike. That kind of makes sense. That's cool to think about. And then I don't know, like a BART station also makes sense. You're coming into the BART and then you're getting on a bike rather than going on a bus. So this data, like we're analyzing it. We're extrapolating. We're figuring out like what these people were thinking, why they went to those instead of others. You do the same with end station names, but this is a great example of group. Are there any questions about why we needed that, why we're using it? It's counting all the things of a categorical variable, right, in common. We can do a pivot based on start and end station. Like, all right, how many started at the Caltrain station and went to Market Street? Like that's a pivot answer, right? Be like dot pivot. And say, all right, from start station name, end station name. That's fun. And this is going to be very unwieldy because there's a bunch of different stations. But at least it puts it in alphabetical order, I think. And I mean, it takes a while to do that, though. There's a bunch of different stations. There's 300,000 different trips that we're dealing with here. But interestingly enough, some of them like start and end at the same station. So somebody like, they went to go, I don't know, pick up their dinner and come back or something. I don't know how that works. But like, that's interesting in itself. But where was the most populous station? San Francisco Caltrain. So like, where's that one? Somewhere over here, probably. I don't think we'll ever find it. Never mind. But like, it looks like a lot of people end up. This is what the start station is on the columns. So they start at the Civic Center for the BART station, and then this column, whatever that is, there were 13 or 14 of them that ended at this particular 11th Street at Bryant Street. Which is cool. Like you can make cool graphs now. You can pick out a start and end station that you cared about. So that's what pivot is good for, like cross-classify, start and end together. That's fun to think about. Dun, dun, dun. We could now, like once we've done this, we know like start and end stations, we can pivot based on a value, like duration. Let's be like, let's see like if this was a race, right? What do we have for these tables? We have the duration as well, right? So if you're cross-classifying, you're going from this station to this station, let's see who, like in the month of June, was the fastest to get there. We can take the minimum duration when we collect the values, couldn't we? We could do that. We could say, all right, pivot based on start and end station. The values I want you to use as you're combining things is the duration column values. And I'd like you to take those values as you're collecting them together. I'd like you to apply the min function to the sequence of things that have the same start and end station. Give me the winners, the fastest people who went from somewhere to somewhere else. So it looks like there was, I don't know, there were 28 people who started at this 10th Street station and came back to this 10th Street station. What was the shortest amount of time they took? Apparently 3 seconds. Maybe it was an accident. Okay, that's cool. That's cool to think about. A lot of these have ones in them, unfortunately, so it's kind of hard to see. Like, where's one that's different? Maybe one of these, like 11th Street at Bryant Street and 11th Street at Natoma Street. So that's like along the same street, kind of. There was 15 of those people, so like that's this one. And apparently the winner took just over a minute and a half to get there. So we took the minimum of all of the duration values to get to that place, starting here and ending here. Does that make sense? How we're calling those functions, like collect all the values and call the min function on it. Collect all the duration values that are the same for the start and end station, call the minimum function on it. That's so cool that we can do that now. Like that's pretty powerful. Like we can answer a lot of questions. Any questions about what I've done so far? Grouping and pivoting. All coming back to us. So like that's fun. You could play around with this data all day long, I think. I think you could come up with some cool graphs as well. Practice. Great way to study. I have another data set that corresponds to this that I stole as well from the Bay Wheels, not Bay Wheels anymore, let's call it, yeah, Bay Wheels. And it's the station data. So like for all these stations, there's information about them. It's called stations.csv. That one's small enough to be just a normal CSV file. So I made a stations table. Data/stations. Oh. So what does that look like? This is going to be really cool. If you didn't know, you didn't read about this yet. This has a station name and then a latitude and a longitude for that station. Like where is it on the Earth? With that, we can make maps with our data science library. It's very, very cool. I don't know which one of these shows us about it. Is it here? Marker? No. Yeah, it's not. If it's not there, marker. No, it's not even there either. It's in your book. Your book will talk about it. It's somewhere in the documentation. Now here it is. It's maps. Data science.maps. Like dots. Circle map. A map. There's a marker map. So you can read these kinds of tables, but I'll just go through it. I'll go through it for you. So it's part of this documentation page somewhere. But here, what I like to do is let's take all these. Like you can have these stations. Let's plot them on a map. So what we do is we say it needs this particular function, this particular part of the library needs stuff in order. So it's like we gotta say stations.select. We gotta get the lat and the long first, latitude and the longitude first. It needs those in that order. And then the station name can come after. So I'm just reordering those columns. Like I needed that in that order because it needs the latitude and the longitude first for what I'm about to use. And then also the station name can't be called station name. Like this library really wants like whatever you want to mark. Like here, it's going to take the latitude and longitude, and then whatever you want next, like at each point that you're going to plot on your map, it wants it called labels instead. So we're going to relabel. Yeah, I think it's just relabeled, right? Station name to labels. So like that's the table I'm building right now. So it's lat long labels in that particular order. Then you can say a different kind of table that you want to do. Let's do a marker kind of table. We're going to say marker.map, and we're going to just give it the whole darn table. It's not even going to need it, any of these other things. So is there like an example here? Not really. So I'll just show you. It's more fun this way. Anyway, so we're going to say it's marker. We want a marker kind of map. Marker.map table. And then I want, it's essentially that whole thing. I want that whole table right there. So boop, let's just give all that to marker.map table. And here's what it looks like. Isn't this cool? So what a marker is apparently is one of those little blue things. And like these are all the stations that are participating in Bay Wheels. Like this is where you could drop off a bike or get a bike. Like there's this one, and you can click on it, and like that was in the labels column. Folsom Street at 19th Street. Isn't that so fun? And you can find whatever the most popular one was. Like you can make little maps. I love that. So that's a thing. You give it the latitude and the longitude if you have that, and we have it. And now we want to do really cool stuff. So we got our below 30 table. These are all the rides that took less than 30 minutes. We have, what do you know, start station names and end station names. Those correspond to the station name column of my station's table with latitudes and longitudes. What if I joined those tables together? And then I'd have latitudes and longitudes in addition to durations and other things for these rows. Interesting. Let's do that. Let's think about it that way. So let's deal with the start station. Like maybe where do these things start? Like that's the question we're caring about. Like where do these rides start? So that's below 30. Let's group by the start station. And we'll do the same game that we did before of like we're sorting by the count. I might as well just go and copy and paste that honestly. But let's sort by the count. or the descending is true. And we'll call that starts. Those are my starting points. And that's how many people start at this particular station versus some other station. So we have those. And then I want to join. All right. So I've got these start station name count. And I like to take the starts table and I like to join it with starts.join. I like you to join it with on the start station name column. That's you. That's the thing that you have in common with this other table called stations. And on that column, it's called station name. It's not start or end, it's just station name. So on the stations table, the station name is what you want to look at, and that's where you're going to attach. So stations, and it's station name where you have things in common. So, hey, starts table, go and join yourself with the stations table. Your column that you want to join with is the start station name. Go and find the matching column values for station name in the other table and like attach any extra rows that it had. So the extra rows were the latitude and the longitude. So that's going to give me this. Isn't that cool? It's like, all right, we attach the lat and the long there, where the start station name was the same as the station name in the other table. Like that's the latitude and the longitude for that particular station. That was the latitude and longitude for that particular station. Does that make sense? Yes.
Is there a way to see if like they don't have something in common with what are omitted from the join?
That is a great thing. I do not know if there's some fancy Python that we could do that I don't think I'm teaching in this class. Probably the best thing that you could do yourself would be you can count the number of rows that you get back and compare it to the original table. And if you see that there's a difference, then you can go like sort it and go looking. But there is a better way. It's called sets. If you want to look into Python sets, you can do a set subtraction. Yeah, good question. Was there any other questions?
Just go up a little bit.
Yeah. To where?
Just right there.
To right here. Yeah, so I computed that first. And then we're like, that's the table I want to join the latitude and the longitude with the other table with.
Where's the below 30 group? What does the below 30 like? Or what is it grabbing?
That was my original table. I only picked out of the original table where the duration was less than 30 minutes long.
Oh.
So 60 times 30 seconds, whatever that was. We let Python do the math to generate that table. Yeah, so we have this now. And oh man, we can do some cool stuff because we have a different number of counts. So there's a different kind of map that we can make now. Because these numbers are different, we can make a map where the marker is bigger where there were more people using the bikes and smaller where there are less people using the bikes. We can do it based on the count number. Does that make sense? Because it's a different number. We can make a bigger label on the map versus a smaller label depending on the count. That'll be fun. So let's do that. All right. The way that you do that, it's in the maps. It's called it's a circle map table. So it's a circle map table, and what it really wants is it wants lat and long. It wants a color, and it wants an area. So we're going to provide an area column based on the count column, kind of like smaller if it's a smaller count, bigger if it's a bigger count. So that's what we're about to do. So I want to actually call this table starts again. I'm just going to replace the table with starts like that. Like this can be the new starts table. That's got more stuff in it now. And so, okay, now to make the map data the way that it needs like something called lat and long and a color called blue and an area column. Like it needs all those things. And here, let's make that table with those names in that order. So we want starts.select. We want the order right, so it's got to be lat, then long. And then we can give the start station name. And we're going to have to eventually relabel that to be called labels again. And then let's take that and add on some columns. So like take those things and then add some columns. This map needs something called areas and colors. So the labels need to be called this. So it's areas. We need an areas column, and that will correspond to how big we want the marker to be on the map. And let's do it based on the count column. So it's not really the same. It's just like you find find a number that looks good to you. You could just use like starts.column, like take the exact same value as count for each piece. or you can mess with it a little bit, like multiply it by 0.5 or something like that. Like you can play around with how big it is on the map, essentially. Like that's just something you play around with and find it right, whatever you need it to be. And let's just always make the colors blue. So if you give just a single value, like you give 42, it will just make as many rows as it needs of that particular value. It's just going to copy it all down. So let's just say the label can be blue for everything. And so that will make this table. So colors is always blue, and then areas was based on the original count. I multiplied it by 0.5, so I made it half the size. And you can play around with this. You could have kept the same one. It's gonna make the marker on the graph either huge or small, and sometimes maybe it was too big to use the original count, and so that's why I did it this way. All right, and that will be, let's call this something. I'll call it not that. I will call this. So that's the table. We also need to do some stuff. We need to relabel. Start station name needs to be called labels. So relabeled start station name. Make that be called labels because it needs that. There it is. Now it's called labels instead of start station name. And that's, let's call that something. Start map data. And so that's my final thing. Start map data. Now we're going to give that to this thing called circle. And that will make my map for me. So I say, hey, and this is the table. It needs those things in that order. So it's going to be circle dot map table. So make a map based on this table. Where is it? Somewhere here. Circle. No, it's not really going to say it right. That's very similar to the other ones. Map table. Just give it that entire table. Start map data. All the labels are correct now that we gave them those particular names. And this is what it looks like. Whee! So I made a bunch of blue circles. And notice that some are bigger than others. And that's what we supplied in our areas column there. If this is like not a good value, like maybe you wanted them bigger or smaller, you can change how this works. Make it 0.25 on there. You play around with that. So now they're a bit smaller. Can make it 0.75. I don't know. Until the circles are as big or as small as you want them to be. But it's like a little hit map. And when you zoom in, they get a little bit smaller. But you can kind of see relatively now like which ones are popular. It looks like this one right here, whatever that one was, there's your Caltrain station, which makes sense. Like that's a very popular station relative to others to want to start your bike journey on. And so you can make these kinds of graphs with circles that are bigger than other circles. Cool. And then what about Oakland? Looks like this is the most popular station, and it's a BART station. Go figure. So that's so cool. You can make these maps and just kind of read them off. So they're most popular in San Francisco, obviously. But we can see that. We can see that now. Are there any questions about this? Gonna follow the process? It's just new library stuff to learn, but at the end of the day, it's just we're messing with tables in a way that we understand now, right? That's pretty cool. Yeah, I think that's most of what I wanted to show you. Are there any questions about this little example? So we got some data, we joined, we grouped, we pivoted, we mapped even. So this is fun stuff to play around with, I think. All right, if we are happy, we do have some extra time. I want you to practice now. So I want to show you something. I want to ask you a question about stuff. So, and then I have just some final things to talk about. So we got plenty of time for it. Let's just remember how to apply functions to tables, because like that's very important. We have functions, we have tables, we want to marry them together. So let's pull up our Fresno temperatures data set. All right, just like one last little example. I will draw a little line even, like to separate these ideas. So one last little review. Let's bring in that Fresno table. That's, what was it? I think it was just like max min. Yeah, it's max min temperatures Fresno. That's the one. So I'll read that in. We'll call it temps equals table dot read table Fresno. No, it was max min. There it is. Those are my temperatures. And so again, we have for a particular date, not of a given year, but of any year, what's the record for the highest high and the lowest low, and when were those records set? So apparently on January 1st, it was 69 degrees at the max back in 98, and it was 21 degrees at the lowest back in 1976. 1976 was a very cold year, apparently. So that's cool. Let's study this table some more with new things that we understand. So let's make first let's make a histogram of the more recent record years. This is a silly thing to want to do, but it's a good example of like applying a function. So like what I mean by more recent is you got the highest high year for each row, for each date, as well as the lowest low year. Let's get the more recent of the two. Does that make sense what I want to do? Let's get the more recent. So like we'll give both of these to a function and we'll pick out the 98. We'll give both of these, 48 and 1976, to a function. We'll pick out the 1976. That was the more recent record. All right, so let's say that we want that. What was the most recent record for high or low? That's essentially us using the max function, isn't it? Because max would do that for us. It would give us the maximum value of two things, and that is a table application example. So that's perfect. We can go back to this. We're going to say table temperatures.apply the max function to not just one column, because max can take multiple things. We'll apply it to the highest high year as well as the lowest low year. It will give both of those values at once per row to the function to generate a new column value. All right, that's how it will look. And by the way, I don't think I said this yet, but when you use the dot, there's a secret thing going on. So like we're going to say our table.apply. We've said table.read table. We said, oops. Or some good, like starts dot select. That's different to calling a function in a sense. Because like when you call a function, here it is, quadruple of 42, we didn't put a dot anywhere there, did we? So this may be silly to talk about, but there is a slight difference there. This is a function call. It's for sure a function. But when you have something dot something, it's not actually called a function call. It looks like one. It is mostly a function call, but it's the dot makes it what's called a method call. If you care about looking this up yourself, that's as much as I want to say in the class. But it's kind of like you're talking to the X thing. You're saying, "Hey X, go do thing Y on yourself." That's kind of implicitly you're asking it to do something for you. So like quadruple, just go call quadruple and give me the answer back. That's a function call. Versus, hey, below 30 table, group yourself. It's like implicitly you're asking below 30 to do something for you. That's what that means. So it's called a method. It's essentially a function that's part of below 30. It belongs to that table. So if you care, that's knowledge for your brain. But yeah, that's what I want. I want the table and I want to apply the max function. So I've got my temps table and I would like to apply. Again, you can look at the documentation for this as well. Like what is it? What does apply give to me? Table.apply. Because there should be an example of, in theory, yeah, here's one that takes a couple arguments. Like this particular function takes two things, and so you got to give it which columns do you want per row for those two things. That's what we're going to do. So, all right, temps.apply. I would like to apply the max function, right? I want to apply the max function. It's just called max. It's built into Python to the columns. So each of the columns, so for per row, it's going to apply this function called max. And how do I want to apply? I want it to apply to the highest high year values and the lowest low year values. So the very first time, and let me just make this first. And so we get this. Like the first one is 1998 because that one wins. The next one is 1976 because that's bigger than 48. Like it's working. What it's doing, if you want to think about it, is just saying for each row, it's like it's calling max and it's getting 1998. For the first one and 1976 for the second one, and it's just calling max. That's what it's doing. That's how it's getting those things. It's saying take the highest high year part, take the lowest low year part, give those to max, give me that value, and make that the first index of my resulting sequence. That's what it's doing. For the second one, it's just calling max again. Call it on 1948 and 1976, and then 1976 wins. Take that, bring it into my array, bring it into my sequence that I care about. That's what it's doing. It's making a bunch of those calls all at once. We're just giving it, we're saying, use that as the first argument, use that thing as the second argument per row. It's applying these things per row to build another sequence, one element for each row of the table. Does that make sense to us? So that's how we get those values. And we can put it back. Like this is now a sequence. We can't do a histogram of an array. You got to put it as a column of a table. So we can attach this, because there's one row per, or one index per row of the table, and bring it back into the table is what we can do. We can attach it. We can be like temperatures, I don't know, dot with column. Let's give this a name, but like that's what I want. That's what I want to put there. Let's call this most recent record year. I don't know. It could be as long or as short as you want, but like there it is. Now it is. I'm putting it there now. Does that make sense? 1998, 1976. That's my new table. All right. Questions about what I just did there? You see it? So that's a useful example of application. And what do I want to do with it? So let's make a histogram now of the most recent record year. So I've got them all in this column called most recent record year, aptly named. I've got this table. I could have called it something like recents or something like that. I don't know. You don't even have to give a name. You'd be like .hist right now. That's fine too. But we can do it in a two-step process. So I got my table. I called it recents. And I want to do a histogram based on the most recent record year. And probably the bins are silly looking. This is not very useful maybe. But it's still kind of cool. You can make your own bins. It looks like, I guess, what's the minimum and what's the maximum? That's probably what we really care about right now. So in order to make a histogram that looks normal, we can supply our own bins, but we need to know like what's the smallest thing, what's the biggest thing. So we can say recents dot, give me the column for most recent record year. I should just copy and paste that, but I'm lazy. Give me that and give me the min and the max. Or we made a function that does that, didn't we? Give me the max and the min at once, please. Of that stuff. Look at us coming back to what we were using before. So it looks like 1895 to 2025, which makes sense. So we can make our bins that way. Let's do by every, I don't know, 10 years. That'll work. That'll work in this case. Perfect. Do a histogram where the bins are np.arange starting at 1895, going up to not exactly 2025, but one more. Let's do up to 2026, right? Because otherwise it would cut it off. And let's go by, you can go by tens, I think. That would be cool. Nice. So it looks like not a lot of records around World War II era, but before and after, obviously, you can kind of see global warming happening. Yes, you can see that the more recent years were the record years. So that's kind of cool and interesting to think about. So yeah, fun looking histograms. The largest amount, like the bin with the most things, of course, is the most recent 10 years, which I guess makes sense in a way. So yeah, that's a fun example, and that was an application of a function to a column, to a couple columns all at once to build a third column, and then we can use that to do our bidding. Are there any questions about that? Because if we're good, I have one last question for you to try, and then we'll wrap up. All right, so I'd like you to take this data set. So it's called max min temperatures Fresno. Make sure to use tab. It'll autocomplete for you as you're trying to read it. But like take that file, please. Read it in as a table. And we now have some options to do the same thing, which is kind of cool. So I want you to try both. So let's say what we really like to do right now is we'd like to find what's called the spread between the highest high and the lowest low for a given day. So for example, on January 1st, the highest high was 69 degrees, the lowest low was 21 degrees. The spread was 69 minus 21, or 48 degrees apparently. Cool. And so you have two options now to compute the spread for every date. You could do and then the second one, right, would be 70 minus 20. Right, and that would give you that. And the next one is 50. And we want to do that for everybody, for every day. So, and build another column with that on it. So to generate that spread, you could do it in two ways, couldn't you now? You could do array-based stuff. You can take this column and subtract it from this column, yes? That's one way to do it. I want you to try that. And then the other way is you could make a function. You could make a function called subtract x and y. You could define that. Here's a good example of a function. It's most like our min-max function kind of, so let me give that to you as a screenshot. max and min. There's an example function. It'll take two things, though, rather than a sequence. So you'll have to change it, but here's an example function definition. You got to say def and give your stuff, but this one will take two things rather than one thing. And you could make a function that subtracts two things, one thing from another, and you could apply it to highest highs and lowest lows, couldn't you? And that would be another way to generate that spread value, because it would do the subtraction and give you back a new array of each answer per row. So there's two ways to do the same thing. I'd like you to try both. I think you'll prefer the first one, but now I just want to give you an example of making like a function and doing stuff. So are there any questions about the question? What I'd like you to try? Try to generate the same thing twice. Give me all the different spreads for each day, so 366 because of leap years, of those subtractions of highest highs and lowest lows. Do it array-based way and do it a table.apply-based way. All right, so give that a try. See if you can calculate it both ways. You're going to get the same answer twice, and then we'll come back and I'll try it with you. Give you a few minutes head start. So really what you're going to say is, you're going to say def subtract, when you make that function. You can call it x and y, call it whatever you want. And then you have to do something you have to give back the subtraction of x and y. So it's a very simple function to make, I think. But it will take two things, not just one thing. There might be following a histogram of cool things you did do. Don't forget the return. Return is very important. You say return and then what you want to get back. There's about 30 seconds left on my little timer here. All right, let's see. Did any questions come up as we were trying to? It's like if we had more time, we could do it all or something. But I do want to answer questions before I give away answers. You ready to see it? All right. So the first one is something that we're pretty happy with, I think. So we've got our temps table. We could just be like temps. Hey, give me the column for highest high. I don't want to type it, so I'll copy and paste it. Hey, give me the column for lowest low, and subtract the two. And then I get all these. Does that make sense? That's one way to do it. And you can do cool stuff with that. Make a histogram. It's kind of interesting to think about. That's a thing. You could also get it in another way. You could say, you could make your little function, be like def subtract. How do you subtract two things called x and y? You just return x minus y. If you give them in that order, at least. It depends on how you want to call your function. But once you have that function, you can use it. You can be like, hey, well, of course it works on just single things. You subtract, what was the first one? It was like 69 and 21. Like, it does work. That's how you call it. It takes the two things, gives you back the third thing. So does the function definition make sense? It's a very simple, silly function. But it's useful for our table because we can be like, hey, temps, I'd like you to apply yourself to, I'd like you to apply the subtract function, to these two columns, highest high and lowest low. Those are the things I want you to use as arguments every time you call this function. Highest high, lowest low. And that's another way to get the thing. That's another way to get the thing we want here. And we get the exact same sequence all over again. Does that make sense? Any questions about that way? I mean, sometimes what you want is going to only be possible with a function. Like, it's not just a subtraction anymore. So you want to do something complicated. And so that's where you're going to reach for the dot apply. But now you know you have options at least. Yeah, we good with that example? All right, that's more or less all that I wanted you to try today. There's just a few last things that I want to talk about before I let you work. So we have another one of those sections where it's like miscellaneous things. Just stuff that you'll come across in your book or your assignments, and it would be confusing if I didn't show them to you now. So let me make two functions. So this function f is gonna not return anything. It's gonna print something. Do you remember what printing does? If you just say print, it just outputs something. So you can be like print hi mom, print hello, and it's always gonna produce output. So like it's gonna take that to, it's like printing just forces output to appear. Yeah. So this f function is just going to do nothing but print 42. This g function, it's not even going to take anything. Just call it without anything. It's going to return 42. Okay, so those two functions. When you call them in Jupyter land, say f, it prints 42, it runs all the code, it prints 42, of course. You call g, it returns 42, but Jupyter is going to print out by default what it gives back because it was the last thing in the cell. The difference between them, though, is huge. All right, this is very, very interesting. Usually in this class, you're always going to say to return. You always want to give a value back so that you could use it in a bigger place. Because I cannot do something like this. I can't say f, call yourself, multiply your answer by 2. Because do you see how f has no answer? F does not give anything back. It does not return anything. So there's no answer to, like, pencil in here. It doesn't get replaced with anything. It gets replaced with nothing at all. You can't multiply no result by 2. So you're going to get a weird output. If it lets you, it will print the 42. You see it there? We called f. It's like, all right, I'm going to call f and multiply the answer by 2. So it calls f, tries to get an answer. F's code runs, it prints the 42, and then it tries to use the thing f gave back, which was nothing at all, and multiply that final answer by 2, and so it gives you an error. It's like none. It's called none. That's the thing that you get back when the function doesn't return something. So, yeah, functions that just print things. If you don't say return, functions that don't return, usually ones that just print, including functions that just print things. What happens is they give nothing back. Give nothing back. So You cannot use them in a bigger context. Whereas with a function that does return something, there's no printing that gets done. It's just like you assume that the call itself gets replaced with the value that it results in. So you can totally say, call G, give me that answer times 2, because G gives me an answer, gives me that 42 back. So this gets replaced with the 42. It's multiplying that answer by 2, and it produces and prints out the final answer of 84. So Jupyter is implicitly printing things for us, and that blurs this line, but I want to explicitly talk about this because of that. Does that make enough sense to us? Like the difference between printing and returning, there's a huge, subtle difference, all right? I guess that was an oxymoron, but you kind of get the idea, I hope. So when you have a return, that's like your call gets replaced with the answer. You cannot use a function that does not return anything in a larger place, in a larger context, because there is nothing that it gives back. It's not getting replaced with its answer because there is no answer. It just does something when you're doing nothing but printing, when you don't say return. Okay? So yeah, I hope that makes sense. Please yell at me if that was confusing. I can try to make more examples. But that's a big thing that you'll care about one day. The last thing I want to show you is just a cool use of apply. So let me make a silly table with columns. Let's make an X column with 1, 2, 3 in it. Let's do another column called Y, and another column called Z. Oops, no, I do not want to do that. Go away, go away. I accidentally hit a key. So let's make a Y and a Z. I don't know, they can be different, that's fine. That's going to be 7, 8, 9. So just a table with 3 columns. That's my table T. So it's got some stuff. X, Y, and Z, it's got some values. Got 3 rows total. Let me make a function. It's like what I want to do. Let's say, I don't know, I want to do something weird. I can make a function that kind of works like this. Def, I don't know, multiply and add stuff. And I can give it values like A, B, and C. And I can say return do the A times B and then add C to the answer. Like that's a function that I could want to use and be like, hey, table, apply that function to yourself. It's called multiply add. It's just like it's the first 2 things and adds it to the third thing. It's like something silly. You might need this one day. And then like use your X and your Y and your Z as the inputs to the A, B, and C arguments to get those answers. So that's me using essentially every column of this table to apply to this function. Apply each column of the table to this function, all X, Y, and Z, all 3 of them, and produce a final answer as a sequence, 1 value for each row. Okay, so that's kind of a review of stuff. Does that make sense? It's a 3-argument function that's applying to this table. There is some shorthand if you have a table and you want to apply a function to every single column all at once. You didn't have to type out the X, Y, and Z. There's another way. The other option is you could have done it this way. You could have said, called multiply add, made it a function that took a sequence, like an entire row at a time. And it's a little weird the way that rows work. You could have said t.apply multiply add. And I need to teach you how to like make the call still. But if you don't give anything to dot apply, it's going to apply it to each row at once. So if you don't add a column name, your function gets the whole row passed to it all at once. So if you just say t.apply multiply add, you better have a function, multiply add better take one thing, and that thing is the whole row. And then you could get out each piece of the row by asking certain questions. And so does this say anything here? Because like you should be able to take stuff. Ooh. No, take gives you back. Yeah, this is hard because I don't think I've taught you this. And I don't think it's here in the documentation because it's a little complicated. But one day you might need it. There's a way to get out individual rows. I think it's like this. You use brackets, maybe? Like I say, I want the 0th row. No, that's the column. Row 0. Something like that. There we go. Okay, you can ask for, if you really wanted to, you can get the 0th row of the table, and it gives you back something that looks like this. It's a row thing, and it knows what each column was. Like that was the 0th row with X was 1, Y was 4, Z was 7. And that's what you get each time. That's what you get each time you say multiply add. So you could have said, and the way you get something out is you'd be like, if I had t dot row 0, you can say, give me the x item out of it, please. Give me the y item, give me the z item. So like that's the way you could have made this function. It's going to take the whole row at once. You could be like, return row dot item, give me the x thing, multiply it by row dot item, give me the y thing, and then add in row dot item, give me the z thing. So if you forget to say stuff after the name of your function, you don't give columns that account for each argument of your function, it's just going to apply your function to each row all at once, the whole darn row. And so you'd have to go through stuff like that to generate your answer. So I don't know, technically it's less typing to do it this way in a sense, but sometimes you maybe have like a ton of rows you want to deal with, and it might make more sense to do it this way sometimes. But like that is now an option. All right. Are there any questions about any of that? Because I think that's all that I wanted to say. So it's slightly technical, but like you've at least seen it now once. You can come back, search for this code. And I think that's legitimately all that I want in our chapter 8 file. So that's great. We made it. Yeah, the last things that I need to do are release some homeworks and labs, and I'll just like whatever's due, I'll give you at least a week. So let's look at the calendar real quick. Always at least a week. So, and I'll write down write down my promises so that I can schedule this stuff in a second. So it looks like we've got a homework due today, and then nothing a week from now. So I'll do in this order. We're going to do lab 4 due next week on the 17th. Lab 4 the 17th. We'll do the Friday. I like to do Wednesdays and Fridays, right? We'll do homework 4 on next Friday, the 19th. Homework 4 the 19th. And then I want to release project 1 as well. And a project is a more involved assignment. All right, so I want to talk about that explicitly right now. So I'm going to release project 1, and then I'll assign a date in a second. But I want to give you quite a while. All right, so definitely start early. But here's what a project is in this class. So I'll release project 1, and then I'll assign its due date after we decide on it. But you'll go to this page. It looks exactly like all the others, except for one key difference. For projects, you guys are allowed to work in pairs if you'd like. All right, it's a more involved assignment. You are allowed, you're not required to work in pairs, but you can go and find a partner if you would like, and you work together on the same assignment. You can share your file somehow, and once you complete it, you'll still both submit to the autograder separately. And then I'd also like you to please put like a comment or something in Markdown at the top of the file, just like saying like I worked with this person, just to make it easy for me when I look at things. But here's what the project 1 is. It's just a more involved like homework or lab. It's got a bunch of parts. And so I want to give you like 3 weeks or so to do it, I would say. I think that's a decent amount of time. So let me extract this. Sure. Got a bunch of different CSV files, and let me open it. This is what project 1 is going to look like. So there's a bunch of different parts. And so you're going to run all the cells as usual, just like a homework or just like a lab, and it's going to try to teach you stuff. And you're going to study a bunch of different little data sets. You got population growth kind of data sets. View the file browser. You've got some countries where things have happened. You've got a fertility rate. You've got a population in particular, like for years in certain countries. Like the first one is Afghanistan because it's in alphabetical order. You've got a world poverty rate kind of data set. So you're going to study all those kinds of things. And where's the project itself? Go back to that. And it's just going to be very similar. Like all this stuff is similar. You're going to still be doing more or less the same kind of stuff that you've been doing in your lab. And your homework is just going to be more involved. All right, so it's going to take longer. And there's a bunch of different little parts. But at the end, it's just something new, something more to turn in. And so I want to give you plenty of time to do it. But yeah, this is what it's going to look like. It's got a bunch of different CSV files. And it's about like, how is this first one at least is like, how is the world getting better over time? In theory, it is. So that's kind of cool and promising. But that's your project 1. And I want to give you a few weeks to do it. All right, so let's think about this. I think 3 weeks is probably a decent amount. We might have to do less for future projects depending on how quick we get to things, but I'll give you plenty of time for this one at least. The contents of the project are everything that we've just gone up to. So like it needed this last chapter 8 to like for you to fully understand it. So there will be some function stuff, but that should do it. And or like grouping and things. But I think that's it. And so let's look at our calendar. So we are here on the 10th. 3 weeks from now is Wednesday, October 1st. And I think that's when I'm going to make it due. Does that sound good? So plenty of time. You can work on it with a partner if you'd like. It's just a great way to study for things. And by the way, what week are we in right now? Is it week 5? So 6, 7, that's perfect because I promised a midterm on week 9, right? And so this is not getting into any of that. That's fine. So that's great. So this is project 1. I'll make it due on October 1st. All right. And so I've set a bunch of dates. Like the next, we got lab 4 will be due here, 17th. Homework 4 will be due on the 19th. And then project 1 will be due on October 1. Perfect. October 1st. And I think that is all that I wanted to say for the day. Are there any last questions about anything before I let you go off and work on things? All right. That's all I got.